Welcome to Ruby Thursday. I'm Melissa Wanish. This Ruby Roundtable meetup was recorded on September 16th, 2015 and hosted by AlphaSites. We invited Tute Costa, a developer at thoughtbot, to give a workshop on refactoring Ruby. He demonstrates some really awesome tips and tools that you can use to refactor your own code. If you have any questions about anything you see in the meetup, feel free to leave a comment below and I'll forward that on to Tute. If you're in the NYC area, be sure to check us out on meetup.com and join us. Enjoy this recording of Ruby Roundtable. All right, so hi, my name is Melissa Wanish, and I am co-organizer of Ruby Roundtable. Welcome. And Ruby Roundtable, we are a meetup that is all about interactive. So we're going to have some interactive live coding, and we want everyone to participate. So ask questions, get on in there. And we're for all levels, so if you have a question, even if you think, oh, other people know it, just go ahead and ask. All right, and just a little bit about me. I'm the founder of Ruby Thursday. It's a tutorial site for junior Rails developers, so feel free to check that out. And I want to thank AlphaSites so much for hosting us. This is our fourth meetup here, and we're so glad that they continue to have us here. So I'm going to hand on over to Catherine, and she's going to tell you a little bit more.
Hi, thank you for coming. Here at AlphaSites, we're a knowledge broker, but we're a knowledge broker and we have a very robust engineering team. You can find out more about us at our website, engineering.alphasites.com. We've got a blog there and just information about us. We're always hiring, so check that out too if you're interested in jobs. But here today we have Tute Costa, who works at thoughtbot currently, and will be talking to us about refactoring. So, hand it over.
Hello, everyone. As it was already said, anytime you want, just interrupt me with questions. That's why we are here. It should be a round table, but we are too many to be coding all at the same display, so it will feel more like a talk than I would like. So please, just feel free and comfortable to interrupt me and ask whatever you'd like. So I'm going to be talking about simplifying code. If you want to download the code that we will be using to exercise the things that we are going to do, check that URL, github.com/tute/refactoring-workshop. So there is the code that we are going to be playing with today. Question yet?
Is there a Wi-Fi password?
Oh, yeah. It's a we are hiring developers for guests. So we are going to be talking about refactoring patterns. Does anyone know what a pattern is? Can anyone describe that with your own words? Don't be shy. Yeah?
It's a thing that someone or something does repetitively.
Yeah. That's a pattern. What about refactoring? Can you describe? I'm sorry, I'm going to repeat. So it's a description for a series of repetitive tasks for solving a certain description of a problem that comes frequently, that we see repeatedly. What about refactoring? Can you describe what refactoring is? Yeah?
Changing the code around but having you do the same thing.
Yeah?
Well, I would just say it's a simplifying or modifying your code by keeping behavior invariant.
Yeah, exactly, the same thing, yeah. So, and the goal by which we want to change code while making it work the same as it was before, it's not that we want to create more work out of nothing. It's because we gain many advantages, like we get a code that's more maintainable, more readable, more testable, more predictable. So that's the goals of refactoring. Now, the problem with refactoring by itself is that if you start without following any pattern, you might end up in a rabbit hole that never ends. Because you start changing this one file, and that requires a change in that file, and you can end up like the whole day in that situation. And that's a problem, because then you got a big bang refactor, and who tests that? How can you know that it works well? So that's where patterns come along. They say, well, if you see this anomaly, follow these steps, and in half an hour or 1 hour, you will get to a nicer place, keeping the behavior intact. So the tests should be green, and if they are, you should be able to commit and push that code. That's what we are going to see. We already spoke about why. This is I became very passionate about this because people didn't do it in the companies I have been working on until I started working at thoughtbot, where we do it every day, thankfully. And it improves productivity very tangibly. When the code is hard to reason about, every morning that you see a new big file, you have to build context again in your brain about what's going on and how can you modify it to add behavior or fix bugs that you encounter. And another problem that comes along is when your boss, your product owner, or your users say that they want to fix something, they speak a certain language, the language that the front end talks, the language that we use in the real world. Now, the code might be very separate from that language. And so when somebody says student, you might have a user model in your software. So that means that both you have to do a translation and then you new developer joining the team too. We can avoid all of that by refactoring, making the code speak more like real humans in the real world. So we'll start with the first anomaly. This is the most typical one, unreadable code, things that don't read well. Here we got a conditional with a comment, thankfully, that has something that makes no sense. There's a word if that we know what it does, hash, row, a 1, date, and a 0. No idea what that does. Now, because I wrote that line of code before in a past life, past year or something, I know that it's removing duplicates. I know that that's the condition I'm trying to do there. So when you get unreadable code like this, one good thing to do is give it a name. You have a condition that's hard to read. There are like 5 different things going on in that condition. Extract it out, define a new method called remove duplicates, and let the code read by itself. Like now you can say if remove duplicates, and that's code, and that's also the description of what it does. The Ruby community prides itself on this very same thing. It does what you think it does. That's the simplest pattern because it's just syntactical changes. Like, let's say we see that code, and we are like, yeah, this needs a comment. So we add a comment. Let's say that I go there, and I say, instead of probably a comment, I say, remove duplicates condition. Now, this is the human part, right? Putting a name on what that means. This can be converted into code by removing the numeral sign at the left and changing the white spaces by underscore. Suddenly, like Ruby will try to run that. That's a comment that's now also code, executable code. So that's the first pattern that we'll be working on. Let me see if I'm forgetting any point here. I dislike comments. The reason I dislike comments is because they might get out of sync with code. So there's this description of comments as lies waiting to happen. Because you like have a bug, and then you fix it. That means changing the code a bit. And then you run the tests, and they are green. And then you push it to production so that everyone is happy. And in doing that, you forgot to update the comment. So the next week, when your coworker gets to that file, not only will it be confusing, but it will also be misleading. Like you are better off without that comment. Also, they are just unnecessary because in Ruby we can generate our own language. We can convert the comment as we just did there into running code. So this is what we'll be doing right now. Let's see. I already said that. The pattern that we are going to use is intention revealing method. This is the design pattern for making code more readable. And the steps that we are going to do is what we just said. Add comments when we need them, transform the comments into methods. Comments are now code, and the code describes itself. So let's get to work. This is the code we'll be working on. This is I have the tests on the right side. Probably if I make this white background, it will read better. You tell me. Let's see. Mm-hmm. I'm lost now. Very good. And we are back. So I have the codes on the tests on the right and the code on the left. Do you all can read this? Can you all read it? Should I make it bigger or something? Behind too? Okay, good. So we already have comments here. So I will just convert them into code. We have a controller, Rails controller here, project controller with an index action. Let's see what this does. This is like already confusing. We have no idea what's going on. There's no way we can, like, in reading the first sentence of this paragraph, if we consider it a story, there's no way that we can understand what's happening there. Our goal is to make this so that the first minute that somebody sees it, the first 20 seconds, they have a pretty good idea of what's happening. Now we have to read both the code and the comments. There's a lot of noise going on in there. We'll strip it out. There's a conditional in index action that has occupies the whole body of that method, and we set the project's instance variable, which sometimes is all the featured projects as in this line, and sometimes it's the current user's active projects. The condition is a bit confusing, so we'll have to discover what's that doing, and sometimes we set a flash message when something happens. So let's see. As I said, I will start by stripping out this numeral sign and then convert this into code. When user is admitted at least a week ago, we show its active projects. I will rename this to user admitted a week ago. So this will be now the condition. And because it's a condition, I will extract the method here. User admitted a week ago. Because it's a condition that returns a Boolean, I will add a question mark at the end. So it reads like English. I lost the code, so I will search for it again. Come back here, paste it. And so now we already simplified a bit that first line. Let's do this with the other conditions. I will do it with this one. If not admitted, we show some feature projects and set a marketing flash message when user is new. So here I will extract this to user is new and do the same thing. Define a new private method and paste here, whoops, I did the same thing, that condition. Let's see if the codes are passing. I think I'm forgetting a question mark there. That you can see about how to backfill tests so that you can actually refactor later. But don't touch code if you don't have tests, because these things are changing subtle behavior constantly that we cannot be aware of all of them typically. So we will break the application otherwise. So because I do trust my tests, I consider this a step forward and I already call it better. And as I have said, I could go on. And it's in my judgment to continue doing this for as long as I want, or as long as it's needed for, or just stop here and continue with the next story. Or refactor code that's in worse shape than what's this right now. There is some repetition here. That might be okay. Probably there's a class that's 500 lines, and that it's impossible to understand. So basically how it feels for yourself. I try to do small steps, always small steps, less than an hour. Be able to commit and send it to code review. And try to push it as fast as possible. And then see if it makes sense for your business and your customers and yourself to continue doing it or not. There are many things to say there. It depends also on your team, on your type of application, on how many errors can you afford, if you're in crunch mode, whatever it means or not. So I don't know what to say. Like small steps, if you know that they are better, go for it. And consider it done. And if you need to do something else right now, it's okay. Just leave it there. It's already there. Any other question on intentional revealing method? Yes?
That's what you just said. What is the thing that you get to have test before you do it? What is the minimum test we have or make sure that the code is not working? That if you have some tasks to work on, you have a ESP file, and you don't know where to start, and you don't know when, then the perfect person says a test.
Yeah, experience will tell you. The third pattern that we're going to see today and the last one digs into that question particularly. So I will come back to that question and answer. Okay. Go on. Or any other question before I have time? Okay. We'll move on. This was good. Thank you. This is the code that you will see in GitHub if you go to GitHub. There's 4 exercises. We're going to see 3 today. There is a README in Spanish, a README in English. There are tests. It feels very much like Rails, but it's not Rails. They are plain all Ruby objects. But they are useful to test what we did with Rails. Well, and in applications in general, in everyday life. So coming back to our let's work slide. What we have just done is make the code describes itself. That's the best that we can do ever. And it seems like a very easy pattern, and also very important, which is that's why I put it first. But the truth is that it's not so easy. And the reason why it's not easy is that it implies naming. And naming, as you know, like caching, is the hardest problem in computer sciences. Naming implies knowing how your users speak about the things that you speak in code. Like what terms do they use, does it make sense or not? Naming implies knowing how your objects should behave. Should the user know how to pay, or should there be some external object, or should a bank object know how to receive a payment? And also it implies knowing what counts as business model rules, like things that are specific to your application, and implementation details. All of these are human-like skills. And they seem simple, but they are not. And it requires a lot of conversation. And that's one good reason to try to make the software as close to our client language as possible, so that we can ease this process of exchanging ideas. So yeah, don't be fooled by how simple it seems. It is simple, but it's not easy. We just saw how to fix unreadable code. Instead of revealing method is a pattern that we saw. Now we'll tackle the typical problem that we get in Ruby, which is the nil object. Have you seen this error message and defined method X on nil? Okay, I'm very happy. Then it's going to be useful. We're going to see a pattern that's called net object that's coming right now, and the third one, ginormous method, how to replace it with a method object. And that's where we are going to see how to add tests for it, or see a link that explains how to add tests for it. Okay. The problem with nil is that we can never know where is it coming from. It's such a common object. It can come from a hash with a key whose value is nil. It can come from a hash whose key is just not defined in that hash. It can come from an if that doesn't have the else statement and the condition evaluates to false. It can come from an empty method when you call it. Nil can come from any place. In active record, it comes each time you call find and it wasn't found, and it didn't raise an exception. So when you see a defined method name on nil, it can be in a car, it can be in a blog post, it can be in a user, you just have no idea. So you have to make sense of the stack trace that you hopefully see in your email every day to see where is it coming from, and spend half an hour until you actually spot the source of it. The language should cover for this, and because it does not in the case of Ruby, we have to do it ourselves with a new object. Before introducing the new object idea, if you know that you're about to get a new object, returning a symbol is already better. And the reason is that you can see where is it coming from. Instead of undefined method email or name on nil, it says on guest user in this case. Guest user is a concept of a user that's not authenticated. And that way, we can read on the project or finding project for that string and see what happened. But that doesn't help us with the problem of having to put conditionals everywhere, because even when it's a symbol, that doesn't know how to respond to the name method. And so we have to put a conditional there. And the story goes that we Ruby developers forget about those conditionals everywhere, and so that's when we receive an email from the email notification service that we hopefully have, and then we add the conditional and push it to production. And that's problematic, because we are just spreading knowledge across all the files in our whole application, in the views, in the controllers, in the models, in the background jobs, everywhere. What does the name look like for a user that's not authenticated? We wrote that logic 1,000 times in the same app. There should be a single source of truth for this. And that's when the new object comes into hand. I call this new object null user. It would be better to call it guest user. Let me rename that right now. Which will have the same interface that we expect from an authenticated user. So in this case, it's name. And when we initialize a new user in current user method in a controller somewhere, we will be finding by ID and the ID of the user that might be authenticated. But if it's not found, we will initialize a new object. That way, the code we saw before, where we were saying if you're here, then print your name, but if you're not, say hello guest, we can remove all that logic and just say current user name everywhere. And instead of adding conditionals, we remove them. So this is a beautiful refactor that I can't wait to start. So that's the idea, just initialize a new object, give it the same interface as the one that you are like pretending to be, and remove all the conditionals in the whole application. The only conditional that we have in this case is here in this or. If that's nil, then initialize a new user. And that's a single spot in the whole application that you know if the user is authenticated or not. And then the language takes care of responding to the method that you are expecting. So let's get back to work. We go to special, null object is a special case of the special case object. It typically is null in Ruby, that's why I'm calling it null, but special case objects are useful for anything. It doesn't only need to be when you initialize an empty value. So we have this code right now. It's on the same file so that it's easier to work with it right now. We have a model, which is the user, and it can have many subscriptions. And the only active subscription is the last one. We know that because we built the database, we built all the logic, we know that the last subscription is the active one. All the others will be cancelled. We have a background job that will be sending email to the admins of this application telling what users are there and what subscription are they signed up for. And this is a problematic class. For example, name, here if we see the definition for that method, is checking if the user has the subscription. And if it does, it will print the name for the subscription, but if it does not, it will print none. And the same with status, and the same with trial dates. So our goal will be to remove all these conditionals, and because these methods will become so small, our goal will be to remove those methods altogether. The only thing we'll need is a new object encoding what a null subscription looks like, what a no subscription looks like in our application. So let's start. There's another conditional here that I want to remove. The problem is coming from this line, because that line might return null. So let's run the tests. Tests start going, we can start working. Let's remove one conditional and see what happens with the tests. And the tests start failing. They are like, oh, I don't know how to cancel a new object. And I'm like, yeah, I know, you are constantly showing me the new objects when I don't expect them. So let's just avoid that. Let's create a new class called null subscription. Actually, let's go one step at a time. What we want is here to return a new object. Null subscription dot new. So that way, that subscription won't be null. So if we go to the D, this will say, well, there's no null subscription class, so we can define it now. Null subscription now exists. Null subscription exists, but it doesn't know what cancel means. So let's define that method. And what should cancel do in a null subscription? Typically in the application, it was telling Braintree payments to stop that recurring subscription. When you are not subscribed, and somehow the code calls the cancel method, what do we do? Yeah, just a no up, whatever, nothing. So we can leave it like that. We can leave it empty. I will just put a no up here because it makes sense for ourselves. Run the tests, and we are ready. We just removed one condition. I mean, we didn't really remove it. We just moved it here. But the thing is that that's the only one we're going to have. So let's go to last name now. This background reports job. Let's let the subscription respond for its name. All that condition is gone. And now my tests fail because there's no name. So let's define a name method here. Say, run the tests. And it says, well, there is name, but it's not returning none. I think it expects, right? Yeah, none. It's returning nil. So let's make it return none, which is what we expect, what the admin expects to see in this report in the array. Especially compared to this crazy string of characters that we have here. The concept of a null subscription is very simple. It's a none for name, and it's a no up for cancel, and it's like the things that it has to be. And there's no noise. It's a description of what a null subscription means for ourselves. It's higher level language. It speaks more to ourselves, humans, than to the computer. So let's do the other two. I will go and fast forward now. I will do them all together. We have to define status and trial days. Let's run the tests, see them failing, which is a good thing. If it didn't fail, I would worry. And define trial days. And I remember that it had a dash. And define, what was the other one? Status, thank you. And the run green. So let's see the difference. We create the new object, very thin, very nice. We initialize it when we were initializing null. We remove every conditional. And if we wanted to go one step ahead, we could now remove, for example, these methods that are not named any longer. Instead of last name, which just delegates, we can call everything here. And now we don't need this method and so on. So suddenly that class becomes skinny. I will show you. If my editor is not unhappy, let's open this again. So here we want the status for the subscription. And here we want the trial days. Run the tests. They are green. Check the difference. We create the new class. We remove everything else. That's special case object. Create a new object when you were expecting nil. Remove the conditionals everywhere. Any question? Yeah.
Is it ever okay to return nil? So as you introduce the null object, you also return nil from the cancel method. Should we be returning like a symbol from that or something that's not nil, just in case, even though we're not using that value now for later to maybe we run into a nil error, we're returning nil there?
In which concrete case are you talking about? In cancel?
If you scroll to the top of your null object, the cancel method, you have a return the nil off, which
Yeah.
returning nil, so now you've got a nil wandering through potentially at some point, even though you're not using it now. So is it okay to do that, or should we try to return something that's not nil?
Yeah. You want a typed language. Because if I wrote false, I agree that would be more elegant. But it's as useless as nil in my mind. It's like not saying anything of what it is or where is it coming from. And it also acts as falsy. What I would love is the ability to define the typecasting for this class. So this would be to Boolean. And return false. No, return false, I think. That way, if we leave conditionals, if the conditionals are written like that, this ability that we don't have in Ruby would allow us to keep them and do a smaller refactor. You just asked how much to refactor. If we had this API in the language, we could just be done with that and then remove the conditional sometime else. But we already have a better domain model. That's something I would like. Now, false versus nil, they're both kind of ugly. I'd rather do false, but I expect nils in all my Ruby programs. Any other question?
Sorry, so at what point do you stop there? So at some stage you're going to have to return, just to expand on that question, is if you've got an object that's quite complex and quite large, and the API is huge, at what point do you say, okay, nil is fine, and creating this API and no representation of this object is just too big?
You are tapping into the next topic too, which is how to refactor gigantic methods. Is that the question, or?
Kind of. It's just, I'm just thinking about the way I would have done it is, like say the object is somewhat, you don't generate the object, it's defined in the deep dark corners of the gem somewhere, and you bring the test, and you know how to use the object in a couple of ways, but then you pass that object into another side of the gem. Again, it's
Yeah, I'm not sure I follow. Please repeat your question after we see the next pattern, which might be related, and we might tap on that. But if it is not, please repeat the question. Because, right now I couldn't get it, but I'm interested in the discussion. Now I'm interested, though. It seems to me, though, that it's speaking of more high level, more software architecture, than concrete refactors of concrete code. I'm not sure, and I want to talk about that. We just saw undefined method nil. We can deal with them with null objects. We are now going to try to refactor the enormous method, and the way we are going to do it, you guessed it, is with a new object too. Yeah.
Going back to the main object, I've tried to implement that with was an application that has a device for user management. But to implement the main object, it's not very straightforward. So I don't know if we have anybody has experience with that.
Because you want to hook onto the current user method?
That's right. The application we have using the device chain.
Yeah. The way you do that is defining, you have this method somewhere. Let's say that this is your application controller. And device already defines current user. That means that up the stack, there's that method defined. That means that you can override it because we're in Ruby. We can do whatever we want. So instead of doing your own finder here, you can call device's method with supper. That might return null. So you go to device, come back. You might have gotten a user, in which case you already got it. And if you didn't get it, you get your guest user. So it's the same implementation, but instead of writing the finder yourself, you call supper in application controller. And that way you go up the stack in the gems. Make sense? Great. So let's go with this method. I wrote this too. I'm using code that I know. That's kind of cheating. I will show you. There's an export job, which is, this application was for meteorological data. And this was also my first rates application. There's this export job where people could get CSVs of all the data we had, which was a lot of data. And we were importing stations from all around South America with different formats. So some CSVs were formatted differently. Some had the data in rows, others had the data in columns. So I just did this crazy thing where I would translate one format into the other. And the problem with this method was not only that it's enormous and very hard to understand even for myself that I wrote it, but also that this class is already big. It has instance variables. It has other methods that are not related with this method itself. It has this method, and it has just state. This feels like spaghetti code. There's too much context going on, and anything might be affecting the state of anything else because we didn't extract objects with single responsibilities with their own state that you can't modify or pick from the outside, which is how we should be modeling object-oriented software. And this got me thinking for a long while because I didn't know where to start. I didn't want to start refactoring because I would go into the rabbit hole, and worse than that, even if the tests had been green, I wasn't sure that it was going to be working okay. And this was already in production. Like, the scientists that were downloading the data were already happy. So there was no reason to improve it more than I want to know what my application and software is doing. So this is when I discovered these refactoring patterns. And this was the one that I needed to apply, which is called the extract method with method object. I will quote the 4 steps here, and this is going to feel a bit abstract, but soon we'll get into the code. What we do is create the new class, copy and paste the method in the new class. The method that we copy over has no arguments, because the argument we pass to the initializer of the class. We define instance variables. And then if we want, we can apply intention revealing method, which is the first pattern we saw, to the new class. And from then on, we are comfortable again. The reason why we extract a new class and we don't do it in the same file is to avoid state, is to make extra sure that any change we do in this method is not affecting any other method in the same class. We could have done it in the same class, and if it were in the same class, it's already extracted. But it was not, and that's the reason why we do it in a new one. So let's do some work here. I get happy at simple things. And let's open that file, and let's open the tests2 there, and call them, and we are green. So this is the class. These are the 4 steps that we want to apply. create a new class, copy over the class, the method, and so on. And this is the whole method. So it's like around 50 lines long, and it has a lot of things going on. So because I already have the state and I already know what this is doing, I will call the class format A to B. But that's part of the problem of naming. And if this code was written by some other developer, I would have to study before what is it doing and why, or ask the product owners or whoever, so that I can put a good name to this class. So I'll start with format A to B. And then we have to define the initialize method as the first step, which will take the same argument as the method. That you can see here, it takes the file name argument. So I will put it up there. And file name will now be an instance variable for that new class. Then we are suggested to copy over the whole method. So let's do that. Cut all this crazy body and paste it here. Because the name of the class already says what it's doing, I can call this method whatever I want. That's the reason why I had it. This is documentation for the developers. Define the reader, run the tests, we are green. So at this point, we are already a step ahead, and we could already commit this and consider it a step forward, because that class that was 300 lines of code now is 200 lines of code or whatever. That's already a step forward. This crazy concept that was there, which were like hundreds of characters of Ruby code and strings and stuff, has now a name. It's like format A to B. It's like a high-level concept. We can name it. We can talk about it with our friend developers. So this is already a step forward. But now, if we wanted, we could start extracting methods. And another reason why this is easier in a new class than before is that now we don't need to be passing arguments to each method call. So, for example, csv.parse receives a file. So if I had extracted this block of code before, I would have needed to define a method like this, csv.parse, and then pass in the file, and so on. And this starts trickling down, because then that method was big already, and I will need to also extract some methods off of it, and I will need to be sending down all the arguments that we had in the original class. But you will see now how in the new class we don't need to do that. Let's define that. CSV parse, paste the body. And now file won't be available here, because I just won't send it. And now we'll see our tests fail because of that. It says, undefined local variable or method file. So, okay, let's just put it somewhere. Let's define a new method here called file. That will do the file open operation in Ruby. And now, well, I got in a bit of an uncomfortable state, because now there's many variables being referenced from all over the place. If you want, I can continue doing this if you think that it's something useful to learn, until we have a nicer class running. But this is the idea. Every variable that we have can be an instance variable of the class, or a method in the same class. And until the call definition describes what it's doing. Because I know that it reads a CSV and then spits out a string. We could have method calls that say that same thing. Read CSV, and then output the formatted string. If you're interested, we can do it. You can also ask questions, and we can also pause here and continue the talk. I will wait for a minute until I get at least 2 or 3 questions. I mean it. Did this answer your question? Okay, tell me. Thank you, Jake. He has a hoodie.
If you're in a Rails app, where would you typically put these classes? So, classes, I guess you can call them.
Thank you.
Right now, that's all they do, I guess. But where would you put them?
You allow me to talk about this book that I love so dearly. There's a book that describes what I've been talking about, really, how to make our software talk like we humans talk. It's called Domain-Driven Design, DDD. Domain-Driven Design, it's a blue book, it's enormous, and it's beautiful, and it's very well worth it. That book says this class has no real-world representation. This is just an algorithm. This is abstract. This is computation. And as such, it's not a model. A model would be a car. A model would be a weather station. A model would be a measurement of temperature and precipitation. But in this case, it's just an algorithm. It's a formatting thing. So we call that a service. And so that's why I would create an app/services folder on Rails and call this formatter from A to B service and put it there. And that way, I'm telling developers, hey, this is important to our app. People speak about these things, about transforming A to B, but they are not really models. They are just processes that we need to fulfill. I will put it in services. And there are many other names that you could be using. If they are simple enough, I will put them in models. If you have less than 40 models, I'm okay with putting everything in models. But you also might get a presenter so that instead of initializing 5 variables in a controller, you initialize only that presenter that takes care of handling all that data. And then in the view, you can call methods on that presenter. Then you would have an app presenters, if you're big on that. You can have form objects. You can have whatever makes sense for you. Sometimes having more folders for just 2 or 3 files might be more confusing than have them all dumped together into models. So use your own judgment. Yeah.
Some developers would argue to put your plain old Ruby classes in the lib directory because it's your business logic. It has nothing to do with Rails. So if you kind of integrate it with the app folder, which is very Rails, right? You have models, controllers. So you, what would you say to that developer that says you should keep Rails where Rails is and your own plain Ruby classes in the lib directory?
I will say my opinion, my personal opinion, after I do a more rational answer, which is the rational answer is all of the things are about communication. If in our team the standard is to use lib, then let's go all with lib. As long as we are consistent, that serves our goal of understanding where things are and what do they mean. If we don't want to use Rails and we want to use Sinatra because we have that opinion, that's okay, as long as we share a similar set of language and opinions and workflows. My personal opinion about that is that lib is for code that typically you would share. Those are libraries, right? The things that you're including existing applications. You put them in lib. It might be just a class, so it doesn't deserve its own gem. You put it in lib. Now, app has your business logic. That's where the core rules of your business live. Those are your models. Those are your services. And it doesn't mean that they are tied with Rails. Because as you can see here, format A to B is a plain old Ruby object, and it doesn't inherit from active record or action controller or any of the big Rails classes. It's not a helper. It's not included any place where you don't want it to. So I'm totally fine with using app, and I don't think that Rails takes over my code because I put it there. It will take it over as soon as I inherit from something. And what you want to avoid is doing that, inheriting from something. So when you have a big application that's a bit slow to run because it loads everything to run some specs, what you can do is extract logic from the user model, for example, that's inheriting from active record, put them in services, and unit test those without loading Rails, just loading spec helper or test helper. And that way you start moving away from Rails inside of Rails so that everyone seems happy and is happy, actually.
Thank you.
Those were 2. I'm happy, but we should get a 3rd. Also, 1 is from a friend, so that doesn't count.
Just to go back into my point,
Mm-hmm.
try not to play it again. We got a method that wraps find by ID and returns null object. Would you rather that Rails got updated so that find by ID becomes an object rather than null?
Oh, no, I would never change the code from our libraries. That's monkey patching, and that's crazy confusing.
No, I'm not talking about monkey patching. Would you like Rails 5 to say, to change find by ID, return null? Because in my mind, it's a lot more ambiguous to return a new object that isn't really there with respect to how the database,
Uh-huh.
as opposed to explicitly saying, I can't find this thing.
I see. What about a method that's called find or return guest user, for example? As long as verbose as it sounds, it's explicit of the fact that it will never return nil. What do you think of that? So define your own finder. That's my finder, but with a better name. Find or guest user, for example. And then you make sure that it's not surprising. Indeed, it can be surprising. Current user, people typically will expect it nil, as it sounds. So let's say current user or guest. I have done that in my own applications. Define current user or guest, call current user from device, or guest.new. Fourth one, yes.
Yeah, one more.
Welcome.
So I'm familiar with the service pattern. You have an instance method call. Usually indicates this service flavor. There's also policy objects where it's like for fraud reasons, let's say, and they're your own plain old Ruby classes. Would you, and let's say it's a user, right? Because users commit fraud, right? So would you put those plain old Ruby classes, those policy objects, in would you create a folder user in your model and then stuff it in there, or would you put it in your services? Are you strict with how you define your services, or do you let other Ruby flavors go in there?
In general, I am not strict, and I will do whatever makes most sense. Sometimes I'm not sure what that means. I started a new Rails application 2 weeks ago, and I did TDD, like behavior, first a feature spec, then some unit specs, and then like real code. And then I got to permissions, and I had no idea how to implement permissions. It could be simpler, it could be more complex, it could change, or it might not change. I had no idea. So what I did was a spike. And I just tried 2 or 3 different ways of shaping this new feature, which will be permissions, without any test. Like the goal was to probably remove all the code, probably. And that way I could see what felt better. And I came back and forth. I defined an app, services, access policy folder with 2 different policies inside. Then I'm like, no, these objects are too small. I will just stuff them into an access policy Ruby file. But then that file was doing 2 or 3 different things. So I came back to the subfolder layout with different names that now I think I'm happy with. And hopefully I will push tomorrow. So it depends. And in those cases, the best way of dealing with it is just taking the time of implementing them both and seeing if it's better or not. Something I didn't say and I wanted to say. As I said that when it's a step forward, you should commit it and move on, sometimes it doesn't look better. And the best thing to do is to just do git checkout master or whatever, or your branch, ignore all the changes that you have done, and be very happy about it because now you learned. You asked questions about the domain model of your application. You thought that you could model them some way. It resulted that it didn't work for some reason that you hopefully have seen. And that means that you learned about both the software and the real-world problem. So this process of writing code and then deleting it is as productive as writing code and then committing it. I didn't say that, and that's important. And that's related with then decide what's best. There's no way we can predict some things. I will be wrapping up, but I will be here too for more questions. Oh, this is the beautiful talk that got me into this pattern. Therapeutic Refactoring from Katrina Owens in Cascadia Ruby 2012. She starts off with a method similar to the one I just shown, and she had no tests whatsoever. I did have this kind of goal test in which I had format A, and I expected the result to be like format B, which was already computed and I knew was right. She didn't even have that. So in this talk, she goes into the process of defining the tests and how to make sure that she's covering every weird case that was inside of that method, and only then start refactoring it. And she's very clear, and it's a talk I can't recommend enough. These slides are linked from my repository with the exercises, so you don't need to, if you take notes, you're very welcome, but you will also have it in the internet. So we saw these 3 patterns: intentional reading method for making the code readable, null objects for avoiding nil, replace method with method object for being able to refactor very big classes and methods. We had questions time, and we will have it again soon. There are 1,000 design patterns, and there are 1,000 refactoring patterns, and there's 1,000 books on software architecture, and this can be daunting. So I always suggest to follow these 4 rules from Sandy Metz, because when you follow them, you are following most of these design patterns and refactoring patterns, just because they force you into that. So you don't need to even know the names of the things that are written in all these blog posts and books. Because if you try to keep your classes small and your method small and have little state and have as little state as you can in any Rails controller, you will be forced into extracting methods, extracting variables, extracting classes, extracting even libraries. You will be forced to do this. And this leads always to green pastures. Whether you know why or not, they are just good, like, long-term goals. So just follow those 4 rules from Sandy Metz. They are very, very, I recommend them very strongly. And that is all. I could have done it. Yeah, that is all. We are back to questions. And clean all the things if you want to. It will make your life at work happier, and so you will have more time to hang out with your friends. Thank you. Any questions before we go?
I think I'd like to visit the ginormous again.
Okay.
That was ginormous.
So I guess we go to the steps and to the code.
So can you do maybe like 1 or 2 more?
Yeah. So let's see. We had some failures here. Let's see what they were. Dates is not defined. So dates, we'll see. It's used here to build up the data that we are going to spit out. And it's also used there in the CSV parse method that I just took out. So what I'm going to do is do an instance variable with this. This seems important to the whole class. We need to keep track of the dates. Define it as, that's a new array now that we will be able to access from the whole class. So I will define that date here. So now the whole class will have visibility of this instance variable. Did I write it correctly? Let's see. No, I didn't write it correctly. It's dates. So now any method that wants to access it will be able to, and it's going to be referencing the global to this object instance variable. So let's see if that makes my test happier. It might fail somewhere else, but not in dates. Go up. No implicit conversion of string into integer. Oh, I'm scared now. I have no idea what that means. So let's see. Oh, the hash, same thing. Hash is like that. That name also is terrible. What's a hash? Hash is a type in Ruby. It's like, so this comment was useful. I will keep it. And then when we are happy about removing it, we do. So hash, I will do the very same thing. It will be part of the whole class. Hash will have its attribute reader here. We will rename it, hopefully. And run the test again. And we are now green. That's beautiful. I love this. Thank you for asking that. So now, CSV parse. I will rename this to read from format A. Change it here too. And then I want to remove this block of code. And I want to write a new method called write to format B. Write to format B. Paste it. Change this. Go down. Define an end here. Come back to the method. Write to format B. I must have done a typo here. Oh, no, I just didn't write it. Write to format B. And look at this. We initialize an empty string, and then we return it. This seems like useless, so I'll just remove it. And see why did we need that string. Let's search for string, and we see here that we are building up this string. So we can define it here. There are better things to do, but this will work. And then return it. Run the tests. We are green. So now call tells us what it's doing. Read from format A, write to format B. And if we want, we can go to the private methods and see the implementation details of what that means. And on themselves, we can recursively apply this method. And I could go on forever. I love doing this. But that's the idea.
Okay. Yeah. That made it feel manageable now that you've broken out 2 main
Right.
parts of what it's doing and explained that. Okay.
And probably if this writer is used in another class, you will want to extract this one method into its own class and so on. Whatever makes sense in your application. And here we start building our own language in English. I love this. Yeah.
So I'm familiar with attr_reader and reader methods. Is there ever a time where you just would pass the instance variable into the call method? I always just get in the habit of making attr_accessor, attr_reader, attr_writer, but working with people from other languages, they don't really get, they see, okay, the name, I have to explain the name maps to the symbol, but they're like, but why don't you just pass the instance variable? I mean, this is a general question, maybe not specific to the refactor, but
why don't you pass them as arguments, you mean? Like method, parentheses, and a variable inside, and then do something with that variable?
Yeah.
As opposed to having the instance variables with attribute reader and getter and writer?
Yeah. Maybe it's not a good example.
Jake, do you have a good answer for that? Because I kind of forgot it.
So I want to clarify your question. Are you asking why use instance variables versus attr_reader instance variable? Or are you asking why are you using instance variables and storing an internal state versus doing it in a more functional style where you pass in all the arguments? Pass those through each method?
Yeah, just pass them through each method.
So for that, I mean, the best answer I have is we're in an object-oriented language. This is typically the way you do it, and it simplifies things by having this kind of state. That's really the best thing I can. Other than that,
It certainly looks nicer.
It looks nicer, yeah, and probably that's an answer indeed. It will turn into more imperative code if you start doing scripts that accept arguments and spit out an output that you have to grab again so that you keep that state. But yeah, I should take the time to think about a good answer.
It's managing state.
Yeah, like this way you abstract it out.
Yeah.
And if I wanted to apply more logic to the writer of dates, for example, right now I'm shoveling in dates into that array. I might want to add a checker there. So if I wanted to see if the date is already there before shoveling it in, I could do this. I could define a new method that takes the new date and here apply some logic. This would be a writer. So it would be, this is a bad example because I'm using the shovel operator directly on the array. But this would be a writer, though, for the date array. And we can now apply more logic to that writer or that reader, for example, format it differently or whatever, in a way that's transparent to all the existing code. Because the code is already using the writer. I mean, in this case, it's a shovel, so I'm sorry about that example. But typically, it will be using a writer, set 8 or whatever. And you might want to add logic. And you can do so without affecting any existing code. You can do it in a single spot. Yeah. The same with the reader. If you want the title to now be uppercased, you can redefine that getter and call uppercase there. But, yeah, without examples, probably it's not clear enough.
Thank you.
As I get more into functional languages like Haskell and Swift and Flutter and such, I ask myself the same question. So it's a great question, and I don't have a great answer, and I often have a hard time myself coming up with. Every time I add an instance variable, I kind of feel like, oh, gross, I don't want to add an instance variable. But so yeah, I just want to. I feel okay.
I never had a good answer, or I couldn't put out a good answer except for better was more manageable, especially if they were complex. But thank you.
You and you then?
I was going to add that it seems one of the ideas of in object-oriented programming is to depend on the behavior and not data. And so if you just depend on the instance variable, everywhere in your code needs to know that that's an array. Instead of just getting the value you want out of it, let's say you just want a certain date, it would have to know everywhere you want that certain date that it's select the third value in the array, whatever it is, right? And if you just put it behind a method, you can just say get me the third value. And if that data changes to a hash or something else, you just have to update the method that accesses it so update everywhere else.
Yeah.
I just wanted to comment a little bit. I mean, that's actually a good reason. What you just said is a good reason for why I do object-oriented programming. I agree. But this refactoring method out, object refactoring is like one of my favorite refactoring. And I think it's especially good when you start with a method just do something like that. Because you have like these 7 arguments, right? And if you try to refactor it, you'll find that like many of the pieces of the code you're trying to extract into methods are going to have like require like 5 of those arguments, you know. And then so you get this crazy thing. Whereas if you make it a method and you make those 7, admittedly, you shouldn't have had 7 arguments, right? That's the whole point. That's why you're refactoring. So it's hard, right? When you refactor it and make each of those 7 arguments instance variable, there's just so many. Suddenly you go from ugliness to being able to really refactor it so it's beautiful, actually. I mean, because you can keep refactoring down into smaller methods, you don't have to keep passing around arguments. And then you can also do things like you can have accessors for the methods that cache the values, you know, keep everything, so you can have that, at this or whatever.
Yeah.
And then you can, and then some of your methods might actually just have a side effect, and some of them might just return a value. And so you'll wind up, you can actually wind up going from something this big to something that really has like 1 line of methods, over there. That's what's so like the great thing about this particular refactoring.
Great. That's great. I can wait.
How long?
Until the last one goes? Or until it gets really boring? Sorry, say again, I didn't get it.
They want to find you on the internet or something.
Oh, how nerd, I only have code here. So I'm Tute Costa, and this is my Twitter handle, Tute C, T-U-T-E-C. And I work at thoughtbot, and thank you all for coming. This has been fun, and hopefully you had fun too. I hope so.